today I'm going to talk a little bit about how we at Netflix build Gradle plugins. There's going to be some code examples and running stuff from the command line to see how it fails. In addition, if there's some time left at the end, we'll just wander through the Nebula plugins on our GitHub page and talk about some of the nice things they do. Interactive presentations are usually a little bit more interesting, so feel free to ask questions anytime in here. All right, so there will be code examples. It is under my GitHub account if you want to grab it later. So some of the things to think about when you're building some plugins is, what kind of plugin do I need to build? It's always looking through all of the different kind of things already out there in the ecosystem. Is another company going to do it before me? Is Gradle Inc. going to have it into the core? Or can I get away with just doing some build.gradle configuration in the meantime? You really want to be able to respond to other plugins so that you don't throw weird exceptions if people don't happen to do things in the same order that you expect them to. For us, a lot of the developers who use our plugins really want to be able to change various things on the command line when they're doing their Jenkins job. Instead of checking in changes to their build script, just add some little tweaks to make things change. And then how do I go about testing these whole things? So yeah, think about what you want to do. It's definitely a design problem. You're always going to have to think about where it goes. Then you want to do a detailed literature search out there. There are many plugins on our portal. Palantir has some. Lots of companies. The Gradle plugin portal is a great place to look to see what else is out there. Your search foo should be pretty good. So go through and it's like, I think if I was going to call the plugin something, it would be this, and just see what shows up. Most people, from what I've seen, have named their plugin something that makes sense. So whatever, Git SCM or Semver or shading. So usually you can figure out if something out there already exists. So steal or take inspiration from others. So we found some very interesting code in Gradle core that wasn't available. So the basis of Nebula test is just pulled straight out of Gradle core, which is great since they're Apache licensed. And so it's like, OK, we're good with that. So all of our plugins are Apache licensed, so feel free to fork them, take whatever you want from them, things like that. Definitely be careful if it's like GPL or proprietary, but Apache and MIT are pretty nice. And then even if it is licensed, at least see how they're ordering their plugins, how they're doing their tests. Then you're going to spend a lot of time on Gradle.org reading their documentation. So I'd say every time I crack open a new plugin, I'm spend at least a couple of minutes in there. And then the very first plugin I was writing, it's like, OK, I guess all day is going to be reading the Google or the Java doc and the example usage. And then hopefully the other third-party plugins you find have at least halfway decent docs. For us, if our docs are unclear, please file issues, or even better, send us pull requests to make them clearer. But if they're not making sense, we'd like to know, so they're easier to use. You should highly consider creating a base plugin when you're doing something. So have a version of the plugin that configures basically nothing. Just have all of the tasks there, all of the basic structures there, but assume nothing about there. That way, if people don't like the opinions that you put in the full version, they can fall back and still get some of the features you added. So our publishing plugin is an example. So we assume lots of things about what you want your end Maven file to look like. And you might not like all of those things. So there's also a base plugin there that gives people all of the hooks in to add various things. Yeah, then add the opinionated plugin. All right, so to code. So a lot of the plugins are going to have the same kind of basic structure here. I'm going to be publishing things locally and deploying them just to show what's going on. So when you're responding to other plugins, the first naive thing you might try is just going right in and adding the task that assumes that something's already applied. So in this case, I'm assuming that everybody who's going to be using my plugin is going to be applying the Java plugin so that these configurations are present. So I guess the first time I'll actually write out the commands the full way. All right, so that's just going to publish that first bad version to my local repo. And then in my usage example, let's use the first version of that and not have the Java plugin present. So this is going to cause us to fail just when it's configuring the project. So it's telling us, I can't find this property compile on the configuration container. So in this case, the error message is really nice. It's like, OK, something that I was expecting for my plugin to be there isn't there. You can use the stack trace to find the exact line. But for this error message, it's pretty clear. Oh, I always expect everybody using this to apply Java first. OK, so now it lives properly, and I can run the task I add. And then, so my task set up basically copying everything on my compile class path into my build directory. So it's copied in now. The problem with this also way of doing it is, one, I'm assuming that people are applying things, and I'm assuming they apply them in a specific order. So if somebody happened to go and put the Java plugin second, we're going to go back to I can't find compile, because I'm just blindly creating a task with something that doesn't exist. So we then go and try and do something at least a little better. And go on to version 2. So here, I'm checking to see if the project has the Java plugin before going and creating my custom task. This is going to be a little better. I'm not going to fail a build just because they aren't applying the plugin Java. But it's still going to be order dependent. So we go back out. And then using shortcuts to publish. We'll go back in and check out our usage again. OK, so we've moved to the new version of the plugin, 1.1. All right, so if I don't have a Java plugin anywhere, I should go ahead and build. All right, so I no longer crash when people just run something simple like tasks, and we can see that the copy libraries doesn't exist. So if I try to run the task that I add, it's not going to be there. We're properly responding to, hey, the Java plugin hasn't applied. The bad thing with doing the has plugin is it will only work if the plugin is applied before the plugin you're doing. So you're not letting people order plugins in any order. So we go to the third version. Using the with type on the plugin container that John showed earlier today in his talk. So this with type line here is basically adding a closure just to the plugin container. So anytime anybody applies the Java plugin throughout the build, it's going to run this closure and do your configuration. So now you're properly responding to tasks or to other plugins and can have people order their things in any order. You're not like forcing them, hey, my docs say you must apply Java before me. And then to the usage. So yeah, we use 1, 2, and it can be in any order. All right. The next thing we want to show is how you can have people extend your plugins in their build scripts. So in the plugin extensions project, we are going to create a simple extension. So this is just going to be an object that you're going to be placing on the project model. You can set up some defaults here, like in this case, the nice hello world. You can have a really simple task. I'm just going to print line what's in that message block. The caveat here is instead of just doing a property access, just calling message, I'm actually using the getter just because of some magic I'm going to do in the plugin. Because when we set up the plugin, we're going to configure things with the bad pattern, at least going forward. So as of Gradle going back forever, convention mapping has been one of the few ways to let people configure this stuff in their build scripts or later. So hopefully with the new config model, it's going to look a lot nicer. So yeah, I'm adding an extension to the extensions object. I'm adding tasks to the task container and configuring that task with that convention mapping. So when I jump to my usage, all right. So if I don't configure anything in my example, I get my hello world, and then I have access to my extensions object, and it will print hello Gradle Summit. So this is going to let people modify some of the things in your plugins. This is super useful when you're writing something like Gradle Dependency Lock, where I want to let people choose what their lock file is going to be, which configurations they want to lock, things like that. So this gives the user time to configure what your plugin is doing. People at Netflix tend to want to configure their plugins via the command line. I'm sure some other companies want to do the same, so knowing how to do it is fairly useful. This is very similar to the last example. Really simple extension object, really simple task. But we're going to change our convention mapping just a little. So I'm going to check to see if somebody has set a command line property here. So if the project has the property, I can do something. You need to be careful calling project.property, just because if somebody hasn't set it before, that's going to return null on you. So having the if guards there is important. So So I've configured in the build.gradle to skip whatever's in there. I gave it a blank message for the printout. But I can go and override that. So this is going to let people modify things at the command line if they don't want to or don't have the time to go into the build.gradle and change them. So if somebody needs a build out really quick, it's a nice way to go and override things. All right. Any questions about those? Yeah.
Do you have a preference between using Gradle properties such as capital P or round properties such as capital J?
So if I can get away with it, I will tend to do the -p to set them on the Gradle object. So, but it's not a super strong preference. If I'm writing a plugin, I'll go with the -p. Okay. And then we also have something in Nebula plugins called the override plugin. So if I go back to my extensions example, which didn't have any of the command line stuff in there, I can go and pull the plugin from JCenter. Since for some reason I haven't published this one to the plugin portal, which will be rectified shortly after the conference is over. So this one does use the -d kind of style, just because it's the easiest way to be able to change anything on the Gradle object model. So again, this is probably on the sneaky side of what to do with plugins, but sometimes it's necessary. So I have my message configured this way. I know what a property somewhere in my build is called. So I can -d override and then the extension and the property name. So basically, if there is a property anywhere in your Gradle build, you can go and use this plugin to go and change it. It's able to talk to any extension or anything on the project object model. It's just going to kind of skip through the project model and go and see if it can override it. All right, and then we go to testing Gradle plugins. So it's kind of hard to come up with simple examples for these things that aren't completely trivial. So I'm going to pop open some of our plugins to show various things. These all use the Nebula test framework, which can be found on our plugins page on GitHub. So we've created a whole bunch of Spock specs to make things a little easier. So here's our dependency lock plugin. So it's doing some low-level stuff to detect the dependencies and write out JSON files. So we have various different kinds of specs here. So the plugin spec is going to let you do probably the closest thing to unit testing some of this can get. If you want to talk to the Gradle project object at all, this is going to give you a little bit of a wrapper there. So in Nebula test, we have a project spec. It's going to add 3 simple tests to your plugin. It's going to make sure you're idempotent, make sure that you can be applied to a root project and a sub-project and a multi-project build, and do some simple applies and just make sure you don't throw exceptions. So after that, it works pretty much like a Spock spec with the addition of automatically setting up project objects via the tooling model. So if we would jump to and then we'll see if the network gets me. So going to our source code is going to let you see some of the stuff that's set up. So we're going to add these tasks to your build. We're extending another project, our project spec, which is going to set up a project dir, and a bunch of rules. So some of the benefit of this is when you're running a unit test or an integration test, we're going to create some output in a test directory so that you can see what the build is doing after the fact. So just in case that your tests aren't capturing everything that you need to talk to, you can go through and just take a manual look. It's like, what would I expect to find in a command line build? So yeah, helper methods to create subprojects and things like that. And then, of course, we have the level of documentation up here. So a little bit of an example of how to use it. All right, and then integration tests. So depending on what your plugin is doing, so if you have just a bunch of tasks that are talking to various things, it's fairly easy to unit test it. You can isolate it from the rest of the Gradle build. You can inject the containers that you're specifically care about, or if you're doing something that's outside of the Gradle build, say generating a file, you can set up all of the things your task needs. So pretty easy to unit test. Sometimes you're doing things like talking to the Maven publish plugin and trying to change what it does. So that's why we have the integration tests. And that said rewrite because we're in the middle of rewriting this so it works with Gradle 2.4 and 2.5. So under my tests, so the integration spec is going to set up a whole bunch of some more helper files. It's going to pre-populate a build file for you, which you can then go and, okay, so what would I expect somebody using my plugin to put into their build.gradle? So you can just write it out in a groovy string, a helper to look up what that string name is, and then we'll add tasks, some helpers like run task successfully or run task with failure. So, what would you expect somebody on your command line to go through and give you? So if I expect them to, run publish Nebula to test local repository, I can tell it to do that. And then you go through your normal testing. So then this one up on GitHub. So we have a whole level of helpers here. Ability to create directories, create files, write hello worlds, copy resources. It's going to capture all of the build output into a build result. So you will have all of your string output, so you can test for various things. On a run task with failure, you can go through and make sure that the error message that you're printing out is useful to your users. So yeah, and then helpers to check if when you're messing with the at input and at output on your tasks to see if they run or not. We also have some helpers in here to check was the task executed. Do I have my at inputs and at outputs right? Was it up to date? Things like that. So tests to help you figure out if you're doing the right kind of incremental builds. Okay. And then we also added ways to test or to create a kind of a local fake Maven and Ivy repo to help you test plugins that are going to do that. You really want to avoid your tests having to go out to hit JCenter or Maven Central and download a whole bunch of big jars. So we created a DSL to help you create this fake graph. So you can describe single dependencies with multiple versions. It's going to go and create this in a local directory. You can tell it bar depends on foo with a dash. You can insert horrible dynamic versions into your POMs or Ivy files. Things like that. This makes it way easier to test something that really needs all of these examples of different dependencies to go through and check against. So instead of my build taking however long it takes to download 50 megs of jars, I can and finding actual jars in the real world that have the patterns that you want to test. You can create the exact layout that you want. If you don't like that DSL way of doing it, we also have added a more builder syntax for doing it. So yeah, dependency graph builder, add a module, build. And then these are all documented on our wiki up on Nebula test. So how to call the different objects, what the syntax is, what it's going to generate, and things like that. Yeah? Well, they won't have any actual code in there. It is a jar with no code for this example. There are thoughts to, well, if I want to test the compile Java, I'm going to generate some sample source code into my plugin. So it depends on the use case. I would use this dependency graph builder if I'm doing something specifically around how am I going to resolve things, how am I going to lock things, and stuff like that. If I want to see my changes to compile Java are happening, I'm going to generate a source file into my build that exercises exactly what I want to see. So yeah, I wouldn't use these with compile Java. We have some desire to extend these a little bit more, have people be able to add classifiers and things to the directory, but it's on the backlog currently. All right, so a tour of our plugins. We have the Gradle Dependency Lock plugin. This is going to let you depend on dynamic versions of various things. So within Netflix at a minimum, people want to depend on latest.release or major.plus of a library to keep up to date as much as possible. But we also want to allow them to have a stable build when they release. So we created the dependency lock plugin. They can go and depend on whatever dynamic things they want, and then go ahead and generate out a JSON lock file, which is then going to go and enforce all the dependencies. So best of both worlds, integrating frequently, and then most of the teams will go and have a nightly job that locks the dependencies for the day. Keeps people moving at a good rate, but allows that fixed place if some introduced jars into the dependency graph are causing problems. Like some of our teams, like Danny's, has 600 jars they have to deal with, so quite useful to get them working for the day until they can track down who's changed something horrible for them. This is fairly configurable. By default, it's going to lock the first order.
Does it lock the palm as well? Generate a palm?
Okay. So our lock plugin does not do that. The publishing plugin that we wrote does do that. So we don't think that people should, well, okay. At least for the internal builds, we don't think that people should put dynamic versions in their dependencies. So we wrote the publishing plugin to take any dynamic version and go and resolve it and replace that in the POM or the IB file. So this, by default, is going to just lock the first order dependencies, because once again, making that assumption that everything that I publish has all of its transitives as specific versions, I can kind of get away with just locking the first orders. But we know that's not the case out in the open world. So we added a configuration object so you can lock all of your transitives. So yeah, we have a dependency lock extension. You can switch include transitives to true, and then it's going to just go and do the whole world of your your transitive closure, and then you'll know everything that you have there. So this took some inspiration from the Ruby bundler plugin. So now there's also some abilities to update single dependencies and do other things like that. And then you can also set excludes, like never lock these 5 projects who are in my team, and I know we're just always going to want latest.release. Yeah.
Does the global lock affect multiple projects maybe?
Yeah, so the default way of running it is for each subproject and a multi-project, it would create individual locks. Sometimes this is the right answer, sometimes it's not. With the current state of some of the IDE tooling, it can get really confusing when you're deploying, or you have a multi-project and one happens to transitively pull in, I don't know, Guava 14 and one pulls in Guava 18, and they both end up in the war deployment. So we have the global lock there. So on the root project, it's going to go and create a fake configuration, add all of the subprojects, and then do a transitive lock up at that top level and force that throughout the whole graph. So you're going to get some unifying versions across the whole thing, which can be quite useful depending on what you're seeing. All right, and then the Nebula publishing suite. This is currently undergoing a rewrite. We were doing some bad in messing with Gradle internals, so 2.3 finally broke us. So we're rewriting it to be way closer to what if you were configuring the Maven Publish plugin in your build.gradle, the plugin's going to look way closer to that. But yeah, so this is going to do various things like auto detect if it's a Java or a jar or war to do the right kind of publishing. It is going to go and add some metadata to the POMs and the Ivy files. It's going to resolve any dynamic dependencies and put those to default, like static versions, what it's resolving to currently. It's going to let you add who the author of it is, have some extra things like, if you Google around, there's the common pattern for this is how I create a source jar, this is how I add it to my Maven Publish. So just write a plugin so people can skip that boilerplate. So we have a source jar, a Javadoc jar, and a test jar. So people can just do that. And then this will publish Ivy and Maven stuff. So hopefully I can get that up to 2.4 soon, so anybody who happened to use us can move forward. We're looking forward to it internally greatly. And then, if you look on the Maven plugin portal, probably half of our plugins up there are from that suite of things, because there's just a whole bunch of base levels and things that add on to it. Nebula release. So we found out in the world a fairly nice plugin called the Gradle Get Plugin, which is going to help you version your repositories based on the Git tags. But we wanted to configure some of the things that it does. So with this, it's going to have tags in your repo. So it's going to see that the last build you did was on 0.2.0, and you can configure it. By default, it's going to your next build is going to be 0.3.0-dev. So it's going to do the semver kind of thing. It's going to take the last tag on your path and bump the specific version you configure. So you can tell it to bump major, minor, patch, and then it's going to follow various patterns when you create tasks. So currently, our versioning plugin internally, you just call a publish task and you happen to pass its status variables around, and it detects what that status is and does various things. So snapshot, candidate, and release. Here, we're being a little bit more explicit. Having a snapshot task that'll do the Maven style -snapshot, having a dev snapshot, which will do some nice things, dev dot, how many commits it's been since the last tag, plus the hash. Or if you're on a branch, it'll add that branch name for the teams who want that. Candidates, rc.1, and final, it's going to bump the right version. This also will do a little bit of the some of the patterns out there. So having named branches 3.x, 4.2.x, it'll know which number to bump. And then once again, all of the kind of command line changes that you'd expect. I want to bump the major, I want to bump the patch, things like that. And then some helper stuff for our Travis CI builds out there in the world. Yeah.
Hey, I have a question. Benjamin was showing in an earlier presentation that he uses the patch number, he uses the Jenkins job number as a patch number.
Mm-hmm.
How does your plugin support that? Does it work with that?
I do not know off the top of my head. Let's see if I let that be configured. Based on this, I would guess no at this point, but if you really want that, file an issue or pull request. Well, if you really want to start from scratch, you can go look at, if you do a Google search for Gradle-Get, that's what this is based on, and that's fully configurable at that kind of level. So I'm doing some assumptions for what Netflix OSS wanted. Hopefully it's useful for some other people either to base theirs off of or to use if they like the versioning pattern that we chose. And then, yeah, definitely can extend it to other features as time allows. All right, extra configurations. So for a long time, people were like, where is my provided config? Where is my optional config? So that's what this does. All right, so yeah, there's a provided base. It's going to go and add. So yeah, you can, it'll add a provided configuration. So if you happen to not be a war project and you want to list something as provided, you can. And then for optional, there's the syntax for that. You'll just do a comma optional afterwards, and it'll create the right POM for that. All right. You should, if you're doing very many internal builds, you should probably consider having a company plugin. If you're doing a whole lot of plugin builds, you should consider having a plugin. So we want most of our Nebula plugins to have the same assumptions. It's like, okay, well, I shouldn't have to configure every single project individually to where's it going to publish to, what are the tasks we expect, and things like that. So Nebula plugin. So yeah, we have our fun little meme, if it ever loads. But yeah, for the plugin, we're basically documenting what are the things that we're going to set up. So you probably don't want to use our plugin because it's really set to, okay, where are we publishing to on JCenter? Where are we doing whatever? But it can be a good example for how to configure the various things for you. So yeah, so I made a plugin so you can plug in while you plug in.
Why not use the init script?
That is a current debate internally, because the bad thing about having a plugin is since it depends on all of or a large subset of our plugins, it's kind of hard to bootstrap when you want to go to a new version of Gradle. So, well, and then I like just doing the apply plugin a little bit better than having to set up the build script everywhere, but it's kind of personal preference. Nice for the one-liner for everything that doesn't tie into it. It's like, let's just auto set this up and go. And then on top of the plugin, we also have some, so like project plugins, so some examples of those. So possibly useful for something to base an internal one off of, but it's like, hey, we think everybody in our OSS org should use all of these plugins, so just apply this one plugin and you're going to get all of them. All right. I'm way early. Questions? Yeah. Well, we probably will never delete it from GitHub. If and when they release their testing stuff, we'll probably start using it instead of Nebula Test. But honestly, since that's been released, it's been fairly stable. We don't change very much of it. When the new versions of Gradle are released, we'll test it against them. But it should be out there for a while. So I definitely recommend using it now because there's not a whole lot of a better alternative. Yeah.
So you were just talking about the plugin, and you said you prefer to keep stuff in like a plugin instead of configuring stuff.
Yeah.
Boilerplate better project.
Yeah.
So what do you feel about, say, find bugs or things like that, which aren't your plugins, but how do you deal with keeping, say, static analysis filters or files which aren't source files in the plugin? Like, what's your opinion on that?
I think if everybody in your company is using, or whatever, org is using the same rules everywhere, it makes a lot of sense to have the plugin just drop them in place. So yeah, if you look at John's talk from earlier today, they're doing that on some of their projects. So it's just like, if you're a Groovy project, we're going to apply CodeNarc and drop this rule file into this place. So I will tend towards documenting things a lot for my internal users and trying to like eliminate as much boilerplate as possible. So if I could have somebody just do apply plugin Nebula or whatever, or our internal thing, and it saves them from having to do 50 lines of whatever, or even 5, sometimes it can be useful. It's just, then it comes down to how well you're documenting it, so when they're grabbing that internal thing, they know what's going in the background.
I guess you said earlier too that you should have a base plugin, and so if somebody doesn't agree with your opinions, they can override it. So I guess that could fit in somehow.
Right. So you could have a base find bugs, which is if you don't have anything configured, I'm going to drop these rules in place, or I know I have this version of find bugs in my Artifactory and you can't hit Maven Central, so I'm going to set that for you. But then, yeah, have another one on top of it, which is like, I add all of these extra rules on top. All right. Thanks.